Hello friends, and welcome to another episode of Find Your Einstein Friday. My name is Scientist Bond, Covalent Bond, and today I'm going to be sharing another super sweet science experiment. You may be sick of the snow and ice after this storm we had, but I promise this experiment is super cool. Better yet, it's cool as ice. So today, we're going to do an experiment called Let's Get Super Cool and Instant Freeze Water with a process called nucleation, and we're going to channel our inner Elsa. As you know, the freezing point of water is 32 degrees Fahrenheit or 0 degrees Celsius. Did you know that water can be cooled below the freezing point but not freeze until it is disturbed? Okay, I know that seems a little crazy, but it's true. This is called supercooled water. What happens when it's disturbed? You guessed it, it instantly freezes. But why does this happen? We are going to find out. We need to start by talking about nucleation. Nucleation is a process where the molecules in a liquid start to gather into tiny clusters, arranging in a way that will help them begin the crystal structure of the solid. There are two types of nucleation. There's heterogeneous nucleation, which occurs when ice begins to form around a nucleation site. So it could be a physical disturbance or an impurity in the liquid or an irregularity in the water bottle or in the container that it's in. Most samples are never 100% pure water, so most of the time it's heterogeneous nucleation that we observe. But then there's homogeneous nucleation. This occurs when ice forms without any nucleation site. Pure water will freeze in the absence of a nucleation site. Now, how can we picture or visualize this? Think about a jar that has a bunch of little cotton balls in them, and the cotton balls are moving around each other smoothly. This is what water molecules would look like. But to freeze or form a solid, they either need to have a nucleation site, something in the bottle or the container that they're in to start with, or they can arrange themselves in a way to bond into the crystallized structure. Think about this. A great example would be building a house. It's much easier to start to build the house when the foundation is already there, or they have the structure up that you can build upon. And this is kind of like the water molecules. Once one starts the freeze, then the rest of them can build upon it. So this brings us back to today's experiment, instant freezing water. We're going to assist water that has been supercooled, cooled below the freezing point but hasn't frozen, to become a solid and freeze. Now review our materials first. You need about 4 to 6 water bottles. These are 16-ounce water bottles. You need a freezer. You'll need a notebook or a piece of paper for documenting your time. You might use a phone or any other device to video record the results, a Sharpie, and you may need some patience for this one. So some helpful tips before we get started. Have all your supplies ready before you start. Clear your surrounding surface area, and never use glass bottles for this experiment. And as mentioned before, you should have adult supervision. So for this procedure, we're going to start with putting water bottles in the freezer for a specific period of time to get them super cooled but not frozen. We are then going to take them out and give them a tap to help the molecules arrange themselves and to begin the freeze. And right before our eyes, this water should freeze. But let me just say that you might not instantly freeze your water on the first try. It takes a few trials to get the timing right. Listen, you all spent a lot of time trying to learn how to flip water bottles, and this is way cooler. So keep trying and you'll eventually get it. For the sake of this trial, I am using the Stop and Shop brand water. Once you get this down, you may want to try a variety of brands to see which works best. Okay, so let's get started. Now, let me just first say I've done several trials prior to this to see what the best time might be. We did a few trials that had times that were lower, like 1 hour and 15 minutes, 1 hour and 20 minutes, or 1 hour and 30 minutes. However, we never really had our water get to the super cooled point where it would instantly freeze. So then we tried a little bit longer. We did a trial where it was about 2 hours, and then when we looked in the freezer, it was already frozen. So we have found what we think is the best time that we're gonna have you start your trial with. So you're gonna start by labeling your water bottle 1 hour and 40 minutes, and label the second bottle 1 hour and 45 minutes. So what we're gonna do is we're gonna put these 2 water bottles in the freezer. And I do suggest that you put them in a place where they're not surrounded by a lot of other things in the freezer and where they're not touching each other, because when you're gonna take them out, you wanna try and take them out as gently as possible. So here we go, let's put them in the freezer. Place them nicely in there. And I'm gonna leave them there, and we are going to wait. So, all right, folks, here we are, ready to take water bottle number 1 out of the freezer. This water bottle has been in for 1 hour and 40 minutes. Let's see if we have super cooled water and if we can get it to freeze. Remember, when you're taking it out, take it out gently as not to disturb it. Here we go. Ready? And there you have it. It is freezing instantly. Woo! All right, did everyone see that? It's completely frozen. There's a little bit of water on it, and we're gonna find out why soon. Awesome. All right, everyone. Since we got the first water bottle to freeze, I brought in my little helper. This is Mini Bond, and she's gonna help be like Elsa. You like Elsa? No. All right, here we go. We're gonna take the water out, and we're gonna be like Elsa, and we're gonna freeze the water. Are you ready? Yeah, okay. Say nice and slow. Say nice and slow. Okay, ready? Mini Bonds, give it a tap. 1, 2, 3, tap. And it's freezing before our eyes. There it goes. Oh, you are like Elsa, girl. Look at that, everyone. Bottle number 2, we instantly froze it. How cool. Can you say cool? Say super cool. Ice. It's cold as ice, that's right. All right, say see you later, everyone. Let's find out why we froze it. Say see you later. All right, so there you have it. We were able to super cool water and then freeze it instantly. Now, why did this happen? So as you saw, by touching or tapping the bottom of the water bottle, nucleation occurred because the tap encouraged the molecules in the liquid to form a crystal-like nucleus or nucleation site where the rest of the molecules could latch and build upon. Therefore, the entire bottle froze before our eyes. So, we had a few questions to consider earlier. Would the water be super cooled? And if so, which time worked best? In this trial, the water was super cooled, and 1 hour and 40 minutes and 1 hour and 45 minutes worked to instantly freeze our water. The other question we had was, would the water freeze all the way when we started the freezing process? If not, why or why not? So this is actually a really cool fact. As we saw, the water froze, but it wasn't completely solid. Now these have since melted all away, but when we tapped the water bottle, it froze, and then there was some water around the ice. And now the reason for that was the water molecules as ice have less energy than water molecules as liquid. So when they go from liquid water to solid water, they have to give up some of their heat energy. So when we tapped the water and it began to freeze, as the molecules began to form the structure and become a solid, they released some of their heat energy and some of the water was actually warmed up. That is super cool. Now, the last question we had was, would the water freeze eventually if we left it in the freezer? And the answer to that is yes, the water would eventually freeze if the molecules latch onto a nucleation site, such as an impurity in the water bottle. Now, if the water bottle does not have any imperfection or impurity, nucleation would not be able to begin, and the water would stay in a liquid state, even if temperatures were below the freezing point. This state is called metastable. The water stays liquid until something kicks off the nucleation process. So some key takeaways. We learned about nucleation and how water needs a nucleation site to begin to freeze. We learned that water molecules need to be arranged in a very specific way to begin nucleation. And as water molecules freeze and become solid, they actually give away some heat energy. Who would have thought? Now, here's a fun fact for you. Some clouds, like all the cumulus clouds, are made up of supercooled water droplets. Now, this can be troublesome for some airplanes because if the supercooled water droplets hit the plane, they could instantly freeze, leaving ice on the plane, and this could result in a variety of complications for the plane. Can you find out more about how nucleation and supercooled water is used in science? So we're gonna challenge you. We wanna see your supercooled water and instant freeze results. Definitely share it with us. Looks like we're coming to an end of our time. I hope you had fun, but before we go, it's time for your Find Your Einstein Funny. Are we ready? Why couldn't the molecules split up? It was an illegally bonding contract. Okay, all right. Tough crowd. What should you do when no one laughs at your science jokes? Keep trying until you get a reaction. Okay. Why did the white bear dissolve in water? Because it was polar. You know, like a polar bear? Polar. Okay. Well, that's it for today's episode of Find Your Einstein Friday. Follow me, scientist Bon, covalent Bon, as I share more wild and wacky scientist fun. And until next time, think like a proton and stay positive.